Okay, so we're going to evaluate this improper integral. And the way we're going to do that is I'm going to do some side work up front. And I want to just see if I can get the antiderivative here. I'm not going to look at the limits yet. So minus 4x, and that's times cosine 3x dx. Well, let's take a look. And I'm going to try to do it by integration by parts. And to do it by parts, I'm going to say u is equal e to the minus 4x. du would equal minus 4 e to the minus 4x dx. This forces me to choose cosine 3x dx equals dv. And v would equal, let's be careful here, it's going to be sine of 3x over 3, all right? And, certainly someone says it's not an easy integration to do. I think it's doable, so let's put this down. And what do you get? And I'm going to put this over here, doing some side work over here. It's going to be e to the minus 4x times sine of 3x over 3 minus, gotta be careful here, right? Well, I'm seeing something. I'm seeing, the minus 4 e to the minus 4x. I'll bring that in the outside. It's going to be e to the minus 4x dx. And then I see, a 3, and then a sine 3x. Well, one thing I noticed about this is, remarkably, it hasn't gotten more difficult, and it does look similar, all right? So I'm going to say this is done, but I'm going to repeat. I'm going to repeat doing this again. We've done this before. Again, this is equal. I'm going to say, let's write this down carefully, right? So u e to the minus 4x du is minus 4 e to the minus 4x dx. This forces me to accept that sine of 3x dx is dv. And then what do you get over there? You get, let's see, v, and that would be minus cosine of 3x over 3. And I got to, kind of repeat over and over again. Whoops, sorry about that. It's an equal sign there. Let me do this again, see what happens. And what do you get over there? Equals e to the minus 4x sine 3x over 3 plus 4/3. Oh, this is going to be tough, isn't it? So minus e to the minus 4x cosine 3x over 3, and then minus, I'm kind of running out of room, so I'm gonna back up, and I realize this is going to take a little more space than I'm giving it, all right? Put it over here. So let's write this down. Equals e to the minus 4x sine 3x over 3 plus 4/3. We're using integration by parts. It's going to be minus e to the minus 4x cosine 3x over 3 minus, let's put this down carefully. And I gotta be careful here, right? So plus 4, I'll put the 4 on the outside, right? 4 e to the minus 4x dx, and then the v, well, I realize that's a minus now, isn't it? So I can erase this again, put the minus down, put the 3 over here, and you get cosine of 3x. Put little parentheses over there. All right, I got troubles over here, and I wonder what I mean by that is I have a lot of things to simplify over here, but let me write that down for you. So the original integration was e to the minus 4x cosine 3x dx. And then we came up with this over here. I gotta write it down, don't I? And what are you gonna get? E to the minus 4x sine 3x over 3 plus, well, not plus, it's minus, isn't it? I'm distributing, so I get minus 4/9 e to the minus 4x cosine 3x. I just did this, and then it's going to be plus 16/9 e to the minus 4x cosine 3x dx. I'm almost there. And what do I notice here? I notice that this thing here is identical to this thing over here. So what I'm going to do is subtract 16/9 of that integral from both sides. And let me just write this over here. This would be 9/9 over here. So you would get minus, let me see if I did that right. Oh, you know what? I made a mistake here. I just noticed it. That's minus. Again, it's 4/3 times this thing over here. That's going to be 16/9. All right, I'm glad I caught that. So I'm going to add 16/9 to both sides, and that would give me, let's see, 9 and 16 is 25/9. And you would get e to the minus 4x cosine 3x dx is equal to e to the minus 4x sine 3x over 3 minus 4/9 e to the minus 4x cosine 3x, over 9. I got that part done. Yeah, I think that, yeah, did all right. And let me put the fraction mark over the whole thing. That's 3x. And then plus c, I remove the integration symbol, all right, plus c. All right, now what do? I multiply both sides by 9/25. All right, let me put that down for you. And if you did that, I think I get something pretty nice. I'll write this over here, e to the minus 4x, we'll check the key in a moment, cosine 3x dx, and I'm multiplying both sides by 9/25. So 9 is divisible by 3, so I get 3/25. Let's see, e to the minus 4x sine 3x, and now it's going to be minus, let's see, I'm multiplying by 9/25, so what am I going to get? Let's write that down. So minus 4/9, and I'm multiplying by 9/25. 9's cancel, so we get minus 4/25. And then what do you get? Let's take a look. You get e to the minus 4x cosine 3x plus some constant. And the constants, I realize I'm multiplying by some, it's still a constant, by the way. So what I'm going to do, I want to see, did I get the antiderivative? And so I want to point out, we're doing this guy over here, and I do see that written over here. Question is, I'm getting what they're getting, which is this over here. I got that part, over 25, minus, I got this part over here, over 25, plus some constant of integration, all right? So this is a good goal to come to. We got this over here. And so say, yeah, I don't know what I was doing anymore. You want to go back and realize that we're actually doing a limit, right? Now, certainly we're doing a definite integral. So what integral are we doing? It's a long time ago. We're doing this guy over here. So basically what I'm doing is writing down as a limit problem, right? So what's the limit problem going to be? Well, it's going to be this thing over here, but I'll put the limit down later, all right? And I'm going to just, plug it in. And what do you get? Well, you take my antiderivative, and you're going to evaluate it from r to 0. Well, let's do that. And I'm going to get my eraser out. And I'm pretty comfortable that we can evaluate this. for some finite number r, and we'll do the limit later, all right? Let me erase this up here. I'm pretty comfortable that my work led to the same conclusion as my key has. And I'm going to plug in the r now. And if you did that, just plugging in r, what are you going to get? You're going to get, I'm going to write it without negative exponents though. I'm going to write it as 3 sine, and that would be 3r. And on bottom you would get 25 e to the 4r minus 4 cosine 3r over 25 e to the 4r. That's the upper limit. Now minus the lower limit. And what's that going to be? Well, the sine of 0 is 0, so that's pretty simple. And the cosine of 0 is 1. So you can get minus a minus, which is plus. You can get 4. Any of the 0 is 1, so 4/25. All right? Let's look at the key, see if we're staring at that. I'm seeing this. I'm seeing this. And I'm seeing this over here. All right? Now, what do I got to do now? I got to do limit as r goes to infinity. I'm going to write it a little differently, though, because I want to be careful about this. And what do you get over here? 4 over 25 plus, I got 25 and e to the 4r, right, on the bottom. 25 e to the 4r. And on top you get 3 sine 3r minus 4 cosine 3r. All right, limit. This is easy. That's just 4/25. I'm kind of wondering about this, though. Now, what's happening over here? The top is like bouncing around, but it's finite. It's finite number. The bottom is streaming off to infinity. This infinity, no matter what finite numbers go into there, it's going to shrink to 0. So the limit's 4/25. And we are done. Thank you.